Hello, so this is a quick tutorial video on how to use the Gadget for hybrid code. In this one, we're going to particularly look at how to restart the hybrid simulation when you want to not reinitialize the neutrinos. So what I mean by that is if you start a normal linear response simulation run at high redshift, then you assume that a neutrino at the beginning will be linear, and so during the initializations, the neutrino will be computed with the purely linear multi-fluid code. And then as the simulation evolves, the neutrinos will be responding to the nonlinear CDMs and thus evolve slightly differently to how the purely linear code would predict it to be. And if for whatever reason you want to restart your simulation from a snapshot in an intermediate redshift, you don't want the simulation to then reinitialize the neutrinos, because then they lose any additional nonlinearity they would have picked up in the previous redshifts run. So now we have a functionality where it allows you to read in the data file for multi-fluid neutrinos. So then even when you want to restart with a purely linear response and not a hybrid run, then you can still retain the nonlinear information in the neutrino sector. So the only thing different really is in the compile time options. So in the config file, there's an additional option now called mflr_rst. So if you turn this option on, then it tells the code that you would like it to restart the multi-fluid information from reading in the file rather than reinitializing using the multi-fluid code. So let's show you the example that if I don't have this turned on, so if I just have it turned off, and then I'll make the file. So in this case, this will be like restarting like a stock Gadget 4 code where it will only require the previous snapshot for you to start as the initial conditions file. And you can read in, it will read in the CDM's information from the snapshot, and then it will go through the whole reinitialization of the neutrino sector from the very beginning. So we're just going to let this compile. Okay, it's taking a little longer than I expected. Oh, by the way, just to mention that in this case, I did compile with all the other initial conditions options shut off. So you switch off the nginx and you switch off the create grid, and you don't turn on any of the hybrid parameters either. So in this kind of compiling option, the Gadget will know to not generate initial conditions and go look for the previous snapshot files instead. Okay, now that we have the binary, we're just going to copy it through to where we're going to run this test. Okay, and here the folder is significantly smaller because we don't need the files to initialize. So we don't need the power spectrum or the growth rate file. We don't need any of that. So we just have the param file. And in this case, in the initial conditions, we're just going to tell it where to find the snapshots. So we're going back to the linear response folder, go to the outputs, and we're going to fetch the snapshots for redshift of 9. And we change the start time to 0.1 and redshift of 9. And everything else stays the same. We're not converting here, so there's no hybrid parameters. So all the neutrinos stay 0, or the neutrino part parameter stays 0. And okay, let me just comment this out for now because that's not needed for now. So now if I just run Gadget, then you see it starts off normally, and then here it reads the IC file, so it goes to the path that we've set, and it finds the particles from the previous run that we paused at the snapshot, and it reads in the particle information for the CDM and baryons. And then it goes through the whole domain decomposition, same as stock Gadget. And you'll see when it goes through the first time step, it gets to the neutrino part, so the multi-fluid part. it will begin the neutrino multiflow initialization, and it will do all the calculations for each mode exactly the same at the beginning of the linear response run. So this means that Gadget's actually going ahead and calculating purely linear neutrinos. And we know that's not good for us because we want to keep the nonlinearities that we have accrued previously. So I'm going to stop this run because that's not right. Going to delete the some of the files. Okay, so now we go back to the Gadget folder. And we go into the config, and then we're going to turn on this MFLR RST. So again, we keep all the other initial conditions shut off. So no ngenic, none of the hybrid parameters, and no create grid. So Gadget in this case will still think that we are reading a initial conditions from a snapshot and not create its own. But then now it knows to look for the multiflow initial conditions from a previous run. Okay, so I'm just going to make this again. Waiting. Thing takes a while. Okay. Didn't complain about anything, so everything is compiled correctly. Copy this over. 512. And the test. Okay, so now that this binary is the gadget that's going to be looking for the multiflow information in the restart, then we're going to tell it where to find the information. So recall from the hybrid tutorial, we showed that you can find the multiflow perturbations in this ynew file, which contains all the delta and theta for each individual stream. So we're going to tell Gadget exactly the same as the hybrid way, the ynew file, and go into the linear response folder to the outputs and finding where the ynew according to the redshift that we want to restart at. So now when we do the same thing, npr run 32 param, see, Gadget goes through the exact same procedure, finds the snapshot, reads in the CDM particles information, gets the coordinates and velocities and all the other stuff. But then now you see after it finishes the domain decomposition, when it gets to the first time step, here we go. Yeah. Now you see that it says begin multiflow initialization, but this is a restarted run. So read the nonlinear info for ynew instead of using evolve to z. So this tells you that the multiflow code is now reading in the previous information, and it's gonna retain all of the additional power or the nonlinear dynamics that we picked up before. So if you, for whatever reason, your simulation is stopped by the cluster or crashes out, and then you don't want to start from the beginning, you want to restart in the middle, then this is a way to ensure that the neutrino part will be consistent and reads in the nonlinear part. Okay, that's it.